All right, I want to talk about these questions that deal with how many standard deviations or what can you expect to happen. So there's a couple of questions like this on our study guide. I want to go over both of them. So this first question says, a local retailer found that the correlation between temperature and the number of coats sold in their store to be R equals negative 0.60. And so let's analyze that a little bit. This is negative, and it should be pretty obvious that it's negative because as the temperature rises outside, they are going to sell fewer and fewer and fewer coats. So this picture that I have right here, the scatter plot picture, this is just an example of what could be going on. I don't know that it's exact, but this is just an example. As temperature rises outside, people aren't going to buy coats. They just don't. So the number of coats sold is going to decrease. So now as we continue, on a day when the temperature is 1 standard deviation below the mean, so on a day when the temperature is 1 standard deviation below the mean temperature, what number of coats can they plan or expect to sell? Well, we're not going to know the exact number. It's just going to be what's the expected value? What is the model telling you? Well, take a look at this picture here. If this was our line of best fit, on the line of best fit is the point X bar, Y bar. This is always the case. X bar, Y bar is always going to be on your line of best fit. So the average temperature and the average coat sold, that combination, that coordinate is on the line of best fit. So if I were to move 1 standard deviation below the average temperature, in other words, on a day when the temperature is 1 standard deviation below the mean, if I move 1 standard deviation below the average temperature, how do I get back on the line to find the expected number of coats sold? Well, in order to get back onto my line of best fit, I have to take R, the correlation coefficient, and multiply by -1. Now you may say, why -1? Well, I'm moving 1 standard deviation below the average temperature. So because I'm moving below the average temperature, I'm moving in a negative direction. And how many standard deviations am I moving below the average temperature? 1. So this 1 standard deviation below leads me to a -1 right here. If I take R times -1, that will put me back on this line of best fit, which is where I want to be to find the expected value or the projected or the predicted number of coats that they would sell. So if I go to this, let's see here, that calculation would then be R, we are told, is negative point, let's try that again. Sorry about that. Try to use a pen, but I'm thinking I'm gonna have to write with my mouse. Negative 0.6, which is my R, times -1. And negative 0.6 times -1 is positive 0.6. So how do I answer this question? Well, I answer the question like this. The answer would then be the store can expect to sell 0.6 standard deviations above the average number of coats sold. I could also put mean right here. So the store can expect to sell 0.6 standard deviations above the mean number of coats sold. And you can see that this little dark green line is 0.6 standard deviations above the average number of coats sold. So that's how you can answer that question. Let's go to another one that's similar. Okay, so here's another question, same type of question, but the scenario is different. So here we go. A random sample of 150 yachts sold in the United States last year was taken. A regression predicted the price in thousands of dollars from length. So we are predicting the price. The price is our predicted variable, and length is our explanatory variable. So here's what it could look like. Length is the explanatory variable on the x-axis. Price is the predicted variable on the y-axis. So let's continue from there. If we were to do this study found R squared to be 15.3%. What would you predict about the price of a yacht whose length was 2 standard deviations above the mean? So in this one, we were looking at 1 standard deviation. What if we're talking about 2 standard deviations? Well, if I draw this picture, the first thing I need to think about is this a positive relationship or association, or is this a negative association? Well, in general, the longer the yacht, the more expensive it is going to be. Okay, a yacht that is 500 feet long is going to sell for more than a yacht that is 50 feet long. So that's something to keep in mind. This is going to be a positive correlation, a positive association between these two variables. So if R squared is 15.3%, and just by using common sense, I know that I'm going to get a positive association here. That means that R is the square root of 0.153, which is 0.39. If I take the square root of 0.153, I get 0.39. How do I know this is supposed to be a positive correlation and not a negative correlation? Because of the common sense that I used over here for the relationship between length and price. So now let's look at this picture. Remember in the last example, we said that X bar, Y bar is always on your line of best fit. So X bar, the average length, and the average price is right here. If I move 2 standard deviations above the average length, to get back onto my line of best fit, I need to take R times 2 to find how many standard deviations it takes me to get back onto the line of best fit. And that calculation is this. R times 2 standard deviations would be 0.39 times 2, which is 0.78. So what does that tell me in the context of this problem? Well, it's not going to tell me the exact price of the yacht who is 2 standard deviations above the mean, because I don't know what the mean is. But in general terms, we could say this down here. The answer is this. We can predict the price of the yacht whose length is 2 standard deviations above the mean to sell for 0.78 standard deviations above the average or mean price. So if the length is 2 standard deviations above the average length, then the price, or the predicted price, is going to be R times 2, which is 0.78 standard deviations above the average price. So I hope this helps you to answer these types of questions, and I hope you have fun in your stats class.